This video will walk you through using dummy variables for two choices here. So we are looking at the data set Harris 7, which contains data on the monthly salaries for employees based on their years of education, their years of experience, their months of experience, the number of months that they've been with the firm, and a dummy or indicator variable where known as males, where males is 1 if the employee is male and 0 if the employee is female. So this is a dummy or indicator variable with two choices because males only can take two choices, either 0 for female or 1 for male. So the first thing I'm going to do is just run a regular regression, including that dummy variable, and we'll talk about how to interpret that dummy variable, how to interpret the coefficient on that dummy variable, and then do some basic hypothesis testing with it. So my dependent variable is salary because I want to see how salary is impacted by education, experience, number of months with the firm, and whether or not the employee is male or female. Okay, and these are my independent variables. Bring this up. All right, I have labels. I'd like my 95% confidence interval, and let's put this on the same page here. Click OK. So if I look at my summary output, my regression explains roughly 52% of the variation in salary, so not great, not bad. That gets reduced down to 48% once I account for the artificial inflation due to multiple independent variables. Now, the interpretation of the coefficient of males. Since male is 1, it gives you the difference between the two groups. So this 722 tells us that males earn on average $722.46 more than females per month after taking into account education, experience, and the number of months that they've been with the firm. If I look at my p-value here, I see that this coefficient is statistically significant. So whether or not the employee is male or female does have a statistically significant impact on their salary. And there I have my upper and lower 95 percentile. Now, to do the actual hypothesis test, let's say I really want to test, does being male really make you earn more? So I have a positive coefficient there, but let's actually run through and do that test. So I have my hypothesized value. I have my t-stat. I have my p-value lower, p-upper, and p2 tail. Okay, so my hypothesized value is 0. My t-stat will be my coefficient minus the hypothesized value, all of that divided by the standard error of my beta, and then I need to take the absolute value of that entire statement. Okay, so my p-value lower is t-dist, that t-statistic, comma, degrees of freedom, which is the degrees of freedom of my residual, and then comma true. Okay, and my p-value upper is 1 minus my p-value lower, and my p-value 2 tail is 2 times the minimum of my upper and lower. So I can look here. I know that I've set up my hypothesis testing table, at least calculated the t-stat correctly, because that's the same t-stat used on males down here to test that hypothesis that beta males is equal to 0, and hence I get that same p-value two-tail. So I know my entire hypothesis testing table is set up correctly. Then I just need to check my actual hypothesis. So I'm testing, do males actually make more? So my HO would be males make less. So I would look at my p-value lower, and I would reject HO. So I'm going to conclude from that males do in fact make more. Now I can run over and do that same thing on SPSS. And I'll go, so this is using the same data set, go into Analyze, and then Regression, Linear. I have already selected my dependent variable as salary, my independent variables as experience, months, males, and education, all of them in there. Click OK, and you will see I come up with my same 722.46, so that's again telling me males make on average 722.46 more than females. And I want to test, does my beta coefficient on males have a positive impact? And T is positive, so all I have to do is take that significance, that's the significance two-tail, and divide that by 2. So that 0 divided by 2 is obviously still 0. So again, I would reject HO and conclude that males do, in fact, make more money.